So you know how to find arctangent of angles, right? But now I want you to know the graph of the function arctangent. So the graph of the function arctangent looks like this, kind of like that x to the 1/3, but this has horizontal asymptotes. That's pi over 2, and that's negative pi over 2. So let's look at that. That says as x's are going to infinity, the y values are going to pi over 2. As x's are going to negative infinity, the y values are going to negative pi over 2. So this is a super important graph, and you need to know those. So this is going to be one of those graphs I'll put on a future memory quiz. So let's look at this. So when we got all these little iterations, when you have an arctangent of an angle, think about plugging the infinity in inside first. So 3 times infinity, it's infinity. So what's arctangent of infinity? Thinking about it, isn't it pi over 2? Yes, it is. Okay, so this one here, again, you go inside first. So if I put the infinity in here, I have 3 over infinity. Hey, wait a minute. Isn't that 0? It is. What's arctangent of 0? When x is 0, y is 0. So here I'm going to put in infinity here for the x. So pi times infinity is infinity. Sine of infinity. Sine. Hey, didn't we already say that does not exist because it does not go to any one y value? That's right. Okay, how about cosine? Cosine of 2x, 2 times infinity is infinity. Cosine of infinity does not exist. So now be careful, because it's not always as soon as you see a sine or a cosine. Let's think about this one. If I plug in infinity here, I get pi over infinity. That's 0. What's sine of 0? That's 0. Okay, so again, going to negative infinity. So if I put negative infinity here, I get 4 times negative infinity, that's negative infinity. And thinking about what the y value is going to, that's negative pi over 2. And is this the same thing? It is, because negative infinity divided by 4 is negative infinity, so that's negative pi over 2. So all kinds of ugly things going on here. So here we go, going to infinity. So you know e to the infinity is infinity. So arctangent of infinity, pi over 2. How about here? Putting in infinity here, you know that 3 over e to the infinity is like saying 3 over infinity. That's the same thing as saying 0. So arctangent of 0, that's 0. Let's think about this one. E to the infinity is infinity. Sine of infinity, oh shucks, we know that's dne. And this one here, we could rewrite this, right? So I can, if I wanted to rewrite this with the negative exponent in the denominator, oh, now I can really see it. If I put infinity in, I get e to the infinity, which is infinity. 1 over infinity, that's 0. Oh, what happens with this one? I've got the negative exponent, so I'll put the negative exponent in the denominator. But now, oh, this is tricky. If you plug in the negative infinity in here, doesn't that raise it to the numerator? Oh my goodness. So that gives you e to the infinity, that's infinity. Or you could have just left it as it was, e to the negative 3x. So you could see if you plug in a negative infinity here, the negative 3 times the negative infinity would give you e to the infinity, and that would be infinity. Okay, so let's look at this one. So this is saying put in negative infinity. So let's think about this. So, oops, negative infinity, I meant that. Arctan. So e, so it's like saying e to the 3 times negative infinity. What happens when you put negative infinity up there? That's making it go into the denominator, right? So that would be arctangent of 3 over infinity. That's 0. So that's 0. One last one. Same thing. If I put a negative infinity in there, that moves it to the denominator. So that would give you 1 over infinity. So that's 0, and arctangent of 0 is 0. So let's do these guys. So I like to scope out what x values are being used first. I see -1, x equal 2, and x equal 5. Because those are the numbers that I want to make sure I include on my graph here, right? So -1, 2, and 5, and leave lots of room in between them. So let's see, since I gave it first, I'm going to put this one down. X's are going to infinity, the y values are going to 1/2. So I'm going to put 1/2 here, and it's end behavior, right? It's only way out here that the y value is going to 1/2. And then this one says as x's are going to negative infinity, that the y values are going to -1/2. So way out here, it's going to the y value of -1/2. Okay, those two are taken care of. So let's look at this one. Go towards 2 from the positive side. Go towards 2 from the positive side this way. You're going to negative infinity. Go towards 2 from the negative side. You're going up to infinity. So there must be a vertical asymptote there. So we got those two done. Right, so let's look at going towards -1 from the positive side. I'm going to the y value of 2. And if I go to -1 from the negative side, I'm going to the y value of -2. And so that takes care of that one. And let's see, I'll join things together in a minute. So as x's are going to 5, that doesn't say positive or negative, so that means both sides, I have to be going to the y value of 2, right? Y value of 2. Okay, so then this here says when x is 5, y is 1. Okay, so we've got this flying dot here. And f of -1 doesn't exist. Okay, so we can leave an open hole there. All right, let's join our pieces together. So we can join this together, join that together. Doesn't matter where you put that. And then see, I've got this little horizontal asymptote. So I'll just change that and erase that little part right there. So it's good to do these in pencil. And there it is. Okay, let's try one more here. So again, scope out the x values. So I've got -2, 4, and 3. Okay, -2. And look how much space I'm leaving. Whoops, 3 and 4. I'm leaving so much space in between, so I have room to work, right? So in going to infinity, the y values are going to pi, way out here. Going to negative infinity, the y values are going to -pi, so way down here. Then, so I got those two taken care of. As I'm going towards 3 from the positive side, I'm going to infinity. If I go towards 3 from the negative side, negative infinity, it's got to be a vertical asymptote there. So those are both done. Then if I'm going to -2 from the positive side, I go to -4. So -4 is smaller than -pi, right? And then if I'm going to -2 from the negative side, I'm going to 3. And 3 is smaller than pi, right? Okay. As I go to 4, x equal 4, I go to the y value of 1. So there it is. So I'll go towards 4. So I'll put an open circle because I don't know if it can be filled in yet or not. Oh, and look at that. It doesn't exist. So you have to leave it open. And then f of -2 is 3. F of -2. So that fills in that dot. So then you've got the horizontal asymptotes and then this horizontal asymptote.